crystal converter acts like a solar energy collector for high-frequency electromagnetic waves beyond the visible light spectrum. It uses a crystal matrix to capture electromagnetic waves and converts them into usable electrical energy. Here is a diagram of the electromagnetic spectrum. Towards the low end, we have radio waves, then microwaves, infrared light, the visible light spectrum, ultraviolet light, X-rays, gamma or cosmic rays, and then the zero-point energy field. You'll notice on the spectrum that as we go from a low frequency to a high frequency, there's a large increase in energy shown by the peak on this graph. In fact, the energy is equal to the frequency cubed. So if you double the frequency, the energy in that area of the spectrum increases by a factor of 2 to the power of 3, or 8 times. So if you're doubling your energy from the radio waves to the microwaves, your increase in energy is up to 8 times. Sunlight contains a wide range of electromagnetic energy. This energy can be converted into electric current using collectors that act like antennae for the sun's rays. This diagram shows sunlight hitting a solar electric cell. When the sun hits the microantennae that are on the solar electric cell, light energy is converted into useful electric current. Cellular phones also use antennae that collect electromagnetic energy from frequencies in the radio and microwave section of the electromagnetic spectrum. Similar to how solar cells use small antennae to collect the visible light spectrum and convert it into electrical energy, radio and microwave frequencies are used to receive and transmit frequencies that allow a voice to be transmitted or other data to be transmitted through these frequencies. Radios and cellular phones are towards the low end of the electromagnetic spectrum. Therefore, they have very little energy in those waves. By the time we get to the visible light spectrum, there is a substantial increase in energy that the photons at that level can carry, as shown by the formula energy equals frequency cubed. So if the frequency has increased by a factor of 10, the energy level has gone up by a factor of more than 1,000. That same trend continues as we go higher on the spectrum into the ultraviolet, X-rays, gamma rays, and finally into the zero-point fields, where there is a very large amount of energy that can be tapped from the photons at that wavelength, which we'll discuss later, are called virtual photons. Virtual photons are proven scientific theory. They have been theoretically proven and are required by the Heisenberg uncertainty principle, quantum mechanics, quantum electrodynamics, the Casimir effect, the Lamb shift, the grand unification theory, also known as fundamental particle theory. There have also been patents granted for ways of extracting the zero-point energy. One was granted to Franklin B. Mead. The Casimir effect has also been verified by Stephen K. Lamoureux, now of the Los Alamos National Laboratory, a government research center in the United States. And it is also proposed that radio wave and microwave noise in receivers and transmitters that is picked up and recorded is a result of zero-point energy fluctuations. The Casimir effect was first proposed in 1948 by Casimir. This is how the Casimir effect works. Electromagnetic waves exist everywhere. When two metal plates are positioned very close to one another, they filter out waves that cannot fit between the cavity that the plates create. This phenomena is called the Casimir effect. Waves that have a longer wavelength cancel themselves out and cannot exist between the two plates. As you'll see in this diagram, there are many wavelengths outside of the metal plates. Outside of the metal plates, the electromagnetic frequencies can exist in any wavelength, but between the two plates, they can only exist between a certain wavelength or smaller. You'll notice that there's only one frequency in here, or smaller, that can fit. Any other larger waves that try to get in cannot exist between the two plates. They either cancel themselves out or can just not exist there. The imbalance of forces that is created by filtering out electromagnetic waves between the plates causes the plates to be pushed together until they touch. You'll notice in the diagram that the force in between the plates is a lot smaller than the forces pushing on the plates from the outside. This is because any frequency of waves can exist on the outside of the plates, on either side, but not in the middle of the plates, where only certain frequencies can exist. Therefore, there is a low pressure inside the plates and high pressure on either side of the outside of the plates, and resulting inward pressure, and the plates are pushed together. We can extract useful energy from the difference in potential between the plates as they approach each other. Once they touch, we can no longer extract energy from the plates. They need to be separated, and the whole process needs to be started from the beginning. Unfortunately, the process of separating the plates requires more energy than we get when the plates come together. Normally, the energy required to separate the plates should be equal to the energy we get when the plates come together, but any devices used to separate the plates would not operate at 100% efficiency. Therefore, there would be inefficiencies and more energy would be needed to take the plates and separate them. In 1995, inventor John Hutchison came up with a solution to the problem of having to separate the plates after each use. He thought that if the plates were allowed to oscillate in a crystalline structure, that they would never touch and would continue to produce electricity as they resonated inside the crystal lattice. He put his theory to the test and has successfully produced several crystal power converters. Now the process just needs some simple refinements. In this diagram, you'll see the crystal structure around the Casimir plates. In between the Casimir plates, you'll notice that there is a frequency that has been isolated from the electromagnetic spectrum. These plates are pictured here much larger than they would normally be. Normally they would be very, very small, even microscopic. In fact, it has been theorized that the smaller the plates are, the more efficiently they would operate. Our output log for one of the crystals that has been monitored since last July of '99 through to March 24th, 2000. The final output voltage, as shown on this graph, is not stable because the Casimir plates inside the crystal have not been properly aligned in an array where the voltages can be added, instead of canceling themselves out. In some cases, the polarity has even reversed, so the positive has turned to negative and the negative to positive. Therefore, when the voltages are not added to each other and work against each other, the voltage will fluctuate as the Casimir plates compete for dominance. The more the Casimir plates are in alignment with each other, the higher the output of the voltage and the stability of the voltage. How big does the electromagnetic crystal have to be? The Casimir effect takes place on a microscopic and even atomic scale. To get a large amount of electricity, hundreds, possibly even thousands of Casimir plates may be required. Luckily, this should only take up a small amount of space, since each of the plates can theoretically be many times smaller than a pinhead. The electromagnetic crystal converter can be as small as you want it to be. In the initial stages, a reasonable sized unit, comparable with existing batteries, should be complete within 24 months of the start of research and development. To start with, the Casimir plates will be a little bit larger as shown in stage 1. This is, of course, blown up to show more detail. From top to bottom, this Casimir plate would normally not be any larger than 1 millimeter. Most likely even much smaller than that. Stage 2 and stage 3 show the progressive miniaturization of the Casimir plates. And self-powering electrical appliances. Imagine a battery that never loses its charge, or a TV that does not need to be plugged in to a power outlet. Since the electromagnetic crystal converter can be molded into almost any shape, it can be integrated into new electronic appliances or molded in the shape of existing batteries. They would act as a permanent power supply or a permanent battery capable of powering a device without ever having to plug it in. The market for permanent batteries is a multi-billion-dollar-a-year industry. Almost every electronic device or appliance that is being used today can be powered with an electromagnetic power unit. The permanent battery. One of our first priorities is to develop permanent batteries that can replace 1. Standard batteries sold in stores, AAA size, AA size, and watch battery sizes, for example. 2. Cellular phone batteries. 3. Notebook computer batteries. 4. Digital cameras. 5. Other portable electronic device batteries. Applications. In the near future, in the next few years, we would like to have developed high power output electromagnetic crystals capable of powering electric cars, possibly your entire home, portable electronic devices that have their own built-in power supply that never need to be changed or charged, self-powering electronic devices like TVs, VCRs, stereos, kitchen appliances, and all other household and commercial appliances that require electricity. Another area of study that is being looked into at the moment is the possibility of developing paper-thin rollable versions of the electromagnetic crystal converter that can be used for portable power. This would come in a form similar to saran wrap or aluminum foil, where the power pack would be very lightweight and portable, and when required can be rolled out on the ground or used or molded in just about any kind of shape for portable electricity and just about any device that you want to power. Benefits. The electromagnetic crystal converter is a non-consumable and therefore a one-time energy expense. Unlike gasoline and other forms of energy from the electrical utility grid that need to be purchased continuously and are consumable energy sources. Once the customer has paid for the unit, there is no further charges, and the life should be many, many, many years. The crystal generates power day and night, It generates power indoors and outdoors, unlike solar cells that can only be used outdoors and during the day for a certain amount of sunlight hours. Generates power in hot and cold environments. It can be molded in virtually any shape to fit inside of electronic devices, as possibly even as part of the molding or the casing of some electronic devices. It can generate more than 100 times more energy per gram than batteries or gasoline. It actually has an energy potential similar to nuclear fusion if that energy can be sustained and controlled at that level, which would take many years to achieve, but the even low power versions are a very, very good start. Unlike a conventional battery, it never runs out of power. It has no moving parts that can break down or wear out. It does not use chemical reactions that can break down over time. These 2 points mean that the electromagnetic crystal converter can last for a very long period of time because there's no parts that can break down, wear out, or chemical reactions that wear out or break down over time. Another benefit is that it is environmentally friendly, recyclable, and it does not use toxic chemicals or acids like batteries use, or nuclear power reactors, and is certainly not dangerous. It never needs to be charged, has very low manufacturing costs, unless you're getting into the very thin rollable film technology, but even that compared to normal energy sources is very cheap. The majority of the components that are used to make the crystal converter are available in abundant supply and are very, very cheap. Possible challenges. We need to determine how to duplicate a high output crystal in mass quantities. So far, every crystal that has been made has had a different voltage and amperage output. This is largely because the materials that have been used have been non-standardized and very little specialized tools have been used in their manufacturing. The power output on some units are inconsistent, and we do not know how to stabilize them. We do not know if they can be stabilized, but several crystals have had a long time output with steady voltage over many years. We do not know how long they will last. The first generation of high power output units capable of powering possibly a car or home will most likely be very bulky, probably 2 feet by 2 feet by 2 feet, or 2 feet cubed, before they are fully miniaturized. Done before. The law of conservation of energy and the law of the conservation of matter seem to prevent the possibility of being able to extract useful energy from the zero-point energy fields. Even though many physicists and theorists and scientists have proven that there is useful energy that can be tapped and that do produce real and measurable effects. 2, very little research has been done on this field because virtual photons have always been accepted as being real, even though it has been shown and proven that they do produce real and measurable effects, which we will look at in a few moments. 3, some inventors may have stumbled on ways of extracting energy from the zero-point fields, but have been bought out by petrochemical industries or other companies that are interested in selling energy on a continuous basis that needs to be consumed, as opposed to the zero-point fields, which once it is purchased once, it never needs to be purchased again. There's much more profit in selling energy on a continuous basis than as opposed to selling it on a one-time basis. 4. All attempts to tap this energy in the past have consumed more energy than they had produced because of what we have discussed earlier. When the plates are separated after they come together, they do require more energy because of the inefficiencies in the equipment that separates the plates after they come together. 5. Zero-point energy is a field of physics that most people do not understand, and very little research, insufficient research, has been done on this field of energy. Here is a pie graph showing the global energy consumption in billions of dollars. The largest section by far is consumed as gas, or the petrochemical industry, at $912 billion. The next largest sector is the natural gas sector at $600 billion. The next largest is coal at $528 billion. Then nuclear at $192 billion. Then all other sources at $168 billion. This pie graph shows the consumption of energy by market sector. The largest sector is the industrial sector, consuming 37%. The next is transportation at 27%, then residential 20%, commercial 16%. These two pie graphs show the energy consumption trends. The first one has the largest 8 consumers of energy in the world, starting with the United States, Germany, Russia, United Kingdom, South Korea, Brazil, China. The second pie graph shows the fastest growing energy users. If you'll notice, the majority of the countries listed are all Asian countries: South Korea, Thailand, Indonesia, Taiwan, India, China, Iran, and Turkey. And each of these countries have very little energy infrastructure in place at the moment. That means that they have no electrical power grid, or very primitive or crude, unlike we have the power grid we have in North America. So these countries would be very likely very open to new energy technologies that would save them a lot of money in setting up an electrical power grid and using expensive energy sources like nuclear power or gasoline, which are very expensive compared to the zero-point energy. These Asian countries represent a huge future market for this technology. Projected global demand. If we could offer consumers a new energy product that could power their home for 50 years or more for a one-time expense of $1,500 US, instead of the average of $100 to $200 per month, many people would be interested, even if the price of the unit were as high as $5,000. It would pay for itself in a matter of only a few years. We could even offer a financing package that matches their current average energy bill. Once they have paid off the financing loan, they would never again have another energy bill. This would also appeal to anyone using portable electronic devices, like cellular phones, notebook computers, and other devices. They would never again need to worry about having to charge them. They would always be charged. The world energy consumption is approximately $2.4 trillion. In as little as 12 to 24 months, this technology could be ready for full-scale production. With all of its benefits, it seems reasonable to assume that at least 1% of the population would be interested in trying this technology. The biggest problem will be in keeping up with the production to fill demand. Where do we go from here? Action plan. 1. Set up a research and development center and an office. 2. Assemble a research staff, equipment, and materials needed. 3. Prepare test samples for outside verification by universities around the world. 4. Isolate the Casimir phenomena that is occurring. 5. We should focus the research on isolating the Casimir phenomena. 2. Testing new materials that optimize the effect. 3. Align the plates so the voltages add to one another. 4. Find the lowest cost materials. 5. Optimize a manufacturing process that is low cost, fast, and low tech. In addition, we need to create a public announcement of the technology with samples and construction details that can be sent to major universities around the world for independent verification and replication, so that the technology can be properly accepted by the public and verified by knowledgeable and qualified professionals. 7. One option that can be considered is to offer the company as an IPO, like one of the internet companies that are being started up and offered on the stock market, where large amounts of money can be raised very, very quickly, especially with a new energy technology like this, and money for further research and production and distribution can be established at in a very short period of time. 8. We can begin public sales of the technology to consumers and for industrial purposes on a global scale, starting probably with smaller test areas and then growing from there. Another possibility is we can, when we're ready, have celebrity endorsements or other ways of gaining a lot of attention for the technology from credible sources like politicians, celebrities, and sports figures that carry a lot of influence in the public's mind. 9. Continue R&D for further miniaturization and higher output capacity of the electromagnetic crystal converters. Look at some of the research that has been done, some of the documentation, some of the physical review articles, and other information that is available on the zero-point energy fields and virtual particles. First, we'll start with the Oxford Dictionary of Physics, which defines the 1. Casimir effect, 2. Fundamental interactions, which they also mention the virtual particle creation from the zero-point energy fields, the Lamb shift, quantum electrodynamics, the Heisenberg uncertainty principle, vacuum state, virtual state, zero-point energy, electromagnetic spectrum, and the conservation laws. Then we'll look at Richard Feynman, a Nobel Prize-winning physicist from the 1960s, with his famous Feynman diagrams that used the zero-point energy fields and virtual particles in most of his work, and provided much proof for the existence of those energies as well. Then third, we'll look at A Brief History of Time by Stephen Hawking, his famous book where he discusses the theory of the universe and its origins and its possible future, where he discusses virtual particles and virtual particle creation and annihilation, as well as the Casimir plates and the effects that they produce. Here's the Oxford Dictionary of Physics with several important definitions marked on the pages with the red highlights. Copies of this are available. Here's a copy of one of the books on Richard Feynman, A Life in Science, that also has several pages marked, copies of which are also available. Hawking's famous book, A Brief History of Time. Stephen makes numerous mentions of the virtual particles and the zero-point energy fields in many of his theories, and many theories that he discusses that are other people's that he expands on throughout the book. He also discusses the Casimir effect and the unification of physics. Here is a collection of research documents talking about the zero-point energy fields and virtual particles. It includes several articles by several authors about the zero-point energy fields, as well as physical review articles, some of the titles of which you can see here. It also includes articles by Albert Einstein and several other well-known physicists. Here is a copy of the patent application for Franklin B. Mead's system for converting electromagnetic energy to electrical energy from the zero-point energy fields. Copies of this are also available. It is approximately 13 pages in length. Here we have a selection of batteries found at most retail stores. Here's a AAA, a AA, C cell, D cell, and here's one of the crystal converters. Here's the smallest of the crystal converters, the first one that I received in July of 1999. This is the second crystal John sent me. And of course, this is the fourth and the most interesting one so far because it has the highest power output. Now let's have some fun and test the voltages of different sizes of batteries. This is a battery, an AA size, AAA size that you would normally get at a retail store, and the voltage is 1.542 volts. Try the AA size, and we get a reading of 1.346. It's actually reading kind of low. Looks like this battery has been used or is dying out. It should normally be about 1.5 volts. Here's the C-cell battery, and it's reading 1.552 volts. Then the D-cell battery is reading 1.514 volts, so just over 1.5 electron volts. Now we'll do a reading on the crystal converter and see what kind of voltage we're getting. And we're pretty close to 1.6 volts, reading at 1.594 volts. So it's actually the highest power unit here for voltage. The crystal generator to power a calculator. First we'll hook up the positive, then the negative electrodes. And then turn the calculator on. Let's take a closer look and try it out. Seems to work just fine. Now here's the crystal converter powering the travel alarm clock again. When you disconnect the power supply, the display turns off. And as you can see at the back, this is where we normally put the batteries. And the battery was removed. Normally a battery like this fits inside at the back and powers the display. We've removed the battery and replaced it with these connector cables with alligator cables at the end, so we can hook up a battery or any other device we want. Here's the positive terminal, and here's the negative terminal. And there we go. Let's see if we can get lucky and also at the same time power this small calculator. Looks like we barely have enough juice to make it go. We are getting a display, very faint. I don't know if that'll come through on the screen. It's a bit of a clearer view. Turn it on. That's off. That's back on. Press a few buttons. We can get a better view here of both devices being powered. Do an experiment and see if the voltages of the crystal converters can be added in series so we can get more than just the power from one cell, but we can actually double that and triple that and quadruple that. Large one is getting 1.6 volts. The small one is getting 180 millivolts. Let's stack these one on top of the other. Then hook up the electrodes. And let's see what we get. So anything over 1.6 volts would be an improvement. And indeed we are getting 1.7 volts, 1.73. It's fluctuating up and down. We don't have a really good contact here. But it's certainly more voltage than we had before, and it appears to be pretty close to adding the two voltages together. So yes, it does look like the units can be added in series.